Okay. Is this screen big enough for you guys?
Oh, wait. Yeah. It's good enough.
Okay. If it's not big enough, just let me know and I'll make it bigger. Okay, so I'll start from the beginning. Basically, today we're going to be doing this program where we classify different types of irises, which is just a flower. And then we can see that there's 3 types of flowers here. So there's a versicolor, setosa, and virginica, and we're going to classify them. So yeah, you can see here there's two main parts of this flower. There's a sepal, and then there's a petal. And so we're going to find out what type of iris it is based on those 2 parts. So I'm gonna move on for now. Like I said, so this is petal length, petal width, sepal width, and based on that we choose their variety. And like before, we're gonna have a file where we get the data from. I'll send you guys a link once we actually start coding, but you can see there's all these different types of data, and based on that, we're going to make our program. So, okay. I said before that this program is going to be a little bit different than what we've been doing before. So what we did before is called regression. We did the lemonade sales and Boston housing prices programs. But this time we're going to do something called classification. And regression was when we had some kind of equation or something like that, and we predicted a number. But classification is basically just categorizing something. So what we're doing is we're taking all of these different numbers and then we're putting it into one of the categories that are shown here, one of these 3 categories. So, like before, we're going to use the same outline that we used. So first we prepare the data, then we create a model, we train the model, and then we use the model to predict something. Before, we were predicting values, like in the Boston program, we were predicting the housing prices, but this time we're going to be predicting what kind of flower it's going to be. Okay. So, this is an example of what we would have coded if we did this according to the other programs. So you can see here, we're just going to look at this part first. So before, when we were printing independent.shape and dependent.shape, we have the number of columns here. It was 4 and then dependent, so basically our output only had 1. We only had 1 output. But this time, we wanted to have 3 outputs, like this. So let me show you guys in a chart. There are 3 different varieties for this one. There's Setosa, Versicolor, and this is supposed to be Virginica. Okay. Let me change this. Okay, so there are 3 different varieties, and then basically we're going to represent it as numbers. So here we have it says like 100, 010, 001. When we come across some type of data that is a Setosa is going to be 1, Versicolor is going to be 0, and Virginica is also going to be 0. So if let's say we get petal length is 5.1, petal width is 3.5, sepal length 1.4, and sepal width is 0.2. When we have this line of code, that's a setosa. So our setosa is going to be 1, and everything else is going to be 0. But then we have this new line of data, and it's different than the first one. That one is a versicolor. So we're going to have 0 for setosa, 1 for versicolor, and 0 for virginica, because that type of flower is a versicolor. It's not the other two. And then the same one for the last category. So yeah, basically we're just going to be classifying them, and we have, whenever it's a certain type, we're going to put 1 for that. Okay. Yeah, and then this time, like I said before, normally we had 1 output only, but this time we're going to have 3 outputs. So that's why we're going to use 3, and then there's this new thing we're going to use called activation and softmax. Basically, that's just saying we want our output to be in ones and zeros. So that's the only part that's really going to be different. And then we have these new functions to make to compile our program. Categorical cross entropy, and then metrics accuracy. So yeah, these two parts are just the main difference between doing regression and classification. Okay. So you guys might be a little confused right now, but I'll keep explaining it once we make our code. So if you guys can go to Google Drive. Okay. Let me send. Okay, so please open Google Drive, and then we're gonna make a collab program like we've been doing so far. So if you go to New, More, and then it's gonna say Google Collaboratory, you can press that, and then it's gonna make a whole new code like this. And then where it says Untitled 0, I'm just gonna highlight it. So I'm just gonna click on it and highlight it. And I'm gonna name my code iris classification. So that's gonna be the name of my code. Once you guys are, I'm gonna give you guys a little time to make your collaboratory and then name it. And then once you guys are done, say that you're done in the general chat, and we can move on. Okay. I think a few of you guys are done now. So I'm gonna start explaining the actual code. Um, yeah, if you guys have questions or you're having trouble, just ask in the chat, and if you can, try to send a screenshot so that the teachers know what you're talking about. Okay, so now I'm gonna send you guys the link to the data. Okay. If you look in the general chat, there's a link for this is what the data is going to look like for this program. So we have a petal length, petal width, sepal length, sepal width, and then the variety. So you can see it's all like this. And this is an example of what our input is going to look like for this program. There's a bunch of different columns here, and then we want to output our variety. And you can see there's like 3 different kinds here. That's what's different about this program, is that there's not just one type, but there's multiple types. So we need to learn how to code that. Okay. So first we need to import everything. Like we did in the past 2 programs, all you need to do is import TensorFlow as TF and import pandas as PD. Okay, and then, as PD. And then once you're done with that section, press plus code, and then it's going to make a new section. Make sure after you make each section, try running it, just so that you don't have an error. Because if you have an error in the beginning, the end is not gonna work. So yeah, it should have a little check mark there, and that means you're good to go. Okay, and then I'm gonna start in the new section and then give you guys some time to code if you need it. So okay, I just sent a link for the data that our program's going to use. It looks like this. It looks a little crazy, but that's the one that we're going to use for this one. So we're going to go to our program, and as usual, we're going to import the file. So file path equals, and then we're going to have single quotes. Copy the link that I sent in chat, paste it in the single quotes, and then it should look like this. And then basically we're going to make something called iris. It's going to read our file. So pd.read underscore CSV, and then it reads from the file path that we just made here. So, and then that was just taking in our data. And now what we're going to do is I'm just going to print out an example of what the file looks like. So iris.head, and we press run, and now it's working. We have our petal length, petal width, sepal width, and variety. It's all in one chart like this once you say iris.head. Make sure to run it, and then you can see this. And make sure it also has a check mark. Okay. So now what we're going to do is we want to find out the different columns. So like before, we have these different columns, and we're going to use that for our independent and dependent. So I'm just going to say iris.columns and run it. And it's going to print out all of the columns like this. Let me make my screen bigger. Okay. So far we have this, and this part. And make sure you run them all and have a check mark on the side. Okay, and now we press new code. So in this section, we want to make our independent, which is basically our input, and our dependent, our output. So independent is equal to iris. Okay. And I'm just going to copy up to here. So petal length to sepal width is the independent, like this, because this is our input where we want to know all of these information in order to classify it. And then our dependent is equal to iris. And that's just going to be variety, like this. So you can just copy and paste. Once you print out iris.columns, you can just copy and paste it into here and it should work. You press, okay, it's not going to do anything yet. But now what we're going to do is print the shape. So when you print the shape, let me type it first. Basically, you're just knowing the number of columns and rows. So this one has 150 and then 4 columns. That's these 4 different types of information. And this one only has 1 because right now there's only 1 variety. But that's kind of a problem because you can see here there's 3 different varieties: Setosa, Versicolor, and Virginica. And in order to do that, we need this number to be 3, not 1. Okay, I'm going to show you guys how to do that and then give you some time to finish coding it. So right now you can see that we only have 1 type of variety. It's just called, oh, wait, let me go back and I'm just going to show you guys how to name the class again. So if it's called Untitled, oh, you can't see my screen? Okay. I'm going to stop sharing it and then, okay. Can you guys see my screen now? Not yet. Hmm. Okay. I'm going to give you guys some time to write all of these 4 sections down before I move on, and let me know when you guys are done. Yeah, I can copy them. Just make sure to separate the different sections. Yeah. Okay. So while you guys put that in, I'm just gonna continue. So, like I said, we only have we only have one variety right now, but we want three. So how we're gonna do that is we're gonna use this function called dummies, and basically just make a new section in your code, and it's gonna be iris equals pd dot get underscore dummies iris, and then iris dot head so that we can see some columns in our code. And I press run. Okay. So now you can see before we only had one variety, but now we have variety setosa, variety versicolor, and variety virginica. So we have three types. And that's exactly what we want because we need to have different numbers like these to know that we have different types of flowers. So yes. Now we are gonna do basically the same thing with independent and dependent. I'm gonna make a new section in the code. And okay, I'm gonna put iris.column just so that it'll be easier to copy and paste it. We have all the same things as before, but now we have three types of varieties that we can use for dependent. I'm gonna make a new column and a new part of our code, and independent equals iris. And this part is gonna be the same as before. It's just these four inputs and we put them in. And then we have dependent. And we're gonna put these different varieties. So the reason why input has all of these is because that's what independent has all of those because it's the input. And then we have dependent, which is basically just our output. We have three different types of varieties that we put in there. And then I'm gonna do print independent dot shape and dependent dot shape. And when you press run, you need to make sure that it says, so this is the same thing as before, but now it's 150, 3. So yeah, this is what's gonna be now. Now we're gonna make a new section in our code. Okay. By the way, all of the code is in the live lecture notes, so you guys can copy it from there if you're a little behind. But after this part, I'll stop for a little so you guys have time. Okay. So now what we're going to do is we need to make a model for our code to train. So I'm going to make a x equals tf dot keras dot layers dot input shape equals 4. So that's just all of our inputs, and then y equals tf dot keras dot layers dot dense three. Okay, I'm just gonna write this out first and then I'll explain it. Okay, so 3, this time we have 3 outputs, which is why I put that there. And activation softmax is basically, you can see here in our sample input, we have 1s and 0. That's basically what we want to train our program to do. So that's that line. And now we have a model. It's just using keras.models.model. We are just using x and y, which is our input and our output, and then we want to compile it. So compile entropy. And like I was mentioning before, this is the part that's different than what we normally. This is the part that's different from what we normally use in regression. And if you press run on this part, it's not going to do anything, but you need to make sure that you have a check mark, because that means that it's working. I'm going to press new section of our code. Okay, so we are almost done, but now we need to actually train it. And before we were using the epochs, that's what we're going to do again. So we have our independent, dependent, and then epochs. I'm going to make it 1,000, which means it's going to go 1,000 times. And verbose equals 0. So verbose basically just means that normally if you just say epochs, it's going to print out every single time your code is training. But if your program has like 1,000 line, that's really long. So I'm going to add verbose equals 0, which means it's not going to show any of that. And then I'm just going to make a new line that I want to show. So model.fit independent dependent epochs equals 10. So I'm only going to show 10. Probably going to take a while because it's training 1,000 times, which is really long. So yeah, just wait a little bit. But yeah, you can see here. When you run it, the goal, so it's gonna show accuracy on the very side here. Right now mine is 0.9800, which means it's a 98% accuracy. You should probably do it over and over again to get to 98 if it's not already there. But if you run it and it's already accuracy is 98, then that's fine. I'm just gonna try running it once more to see if it can go higher. I don't think it's gonna get any more accurate than that, but you can try. Yeah, so right now it's stuck at 98, which is fine. That's pretty accurate. So I'm just gonna leave it there. Okay. I'm gonna copy and paste my code into the chat, and yeah, you guys should try it on your own and let me know when you guys are done or when I can continue. Okay, I'm gonna move on for now, but it might be a little confusing, so yeah, if you guys have any questions, just ask them in the chat. Okay, so now we finished training it, and basically what we're gonna do is we need to print our predictions on what each type is gonna be, because that's the whole point of our program. So yeah, that's what I'm gonna do. Now I'm gonna print model.predict independent 0 to 5. So I'm just gonna print out the first 5, because if I mean, you can print out like the first 10, but I'm just gonna print out 5 of them. Okay. So this might look a little crazy, but let me do the next part of the code, and then I'm gonna explain both of them. Okay. So yeah, this looks more like what we want, but this one is kind of the same. It's just in a crazier format. So you can see here that we have numbers like 1.000, 1.45, but this is to the power of -8. So basically, these are the probabilities of each type of data being some type of flower. So this is the first line. Basically, it's saying that there's 100% chance that it's gonna be a setosa, but there's also a slight chance that it could be a versicolor or a virginica. We don't know, but it seems like there's the greatest chance that it's going to be a setosa, which is why in this first line, setosa is 1, because it's probably a setosa. And then we can see in the second line, there's the most probability of it being a versicolor, so that one has 1. And yeah, if you print out independent, that's how it's gonna look, but dependent has all of this organized data. It's nice, it shows each number line, and then if it's a setosa or a versicolor or whatever, yeah. So this first one is a setosa, second one versicolor, third one is virginica, and then the fourth one is a setosa, and the fifth one is a versicolor. You could keep going. Like if I print out 10, it just keeps going like that. Yeah. And then let me see if I missed anything. Okay. So now I'm gonna explain a different topic. Yeah, so basically in my program, you can see that we got up to an accuracy rate of 98%. I don't know if you guys remember the Boston pricing program, but our loss, it was pretty large. Like these numbers were not very close to what we wanted. So what you can use is something called deep learning. It's basically like you're doing extra training for your program. So in this program, this is not really related, but we trained our program 1,000 times. That's a lot, but it's not enough to make it totally accurate. So what you're gonna do is use deep learning. Okay. Yeah, so basically deep learning is just extra training. Um Okay, so this is something called a multi-layer neural network. That's like, it's very confusing, but basically the idea is that all of these input layers go through some kind of hidden layer before they get to the output layer. Okay, so normally what your program will look like is like this. You have a bunch of inputs and then you get to an output. But in here, you have like a bunch of inputs, you have 3 layers, and then you get to your output. The idea is that all of these, so this input is going to go to every single hidden layer, and then that one goes to the next one, and so on and so on. So, yeah, this one has like a lot of connections, but I'll explain it like little broken down in a bit. So, hidden layers, I mentioned them before, but what do they do? So, in a perceptron, which is what we were using before, it's called a perceptron. There's only one input and one output. So, like in the Boston housing one, we have all of these types of data and we just get one number as our output. So, you use all of these to calculate one output. It's like a neuron. You have one sensory input and then you output one thing. So this is kind of a more broken down example of what we already did. This is our input layer. We have, this goes x1, x2, x3, all the way up to x13. So we have 13 different types of inputs. But to make it more simple, I'm just gonna say has 5 for now, okay? And then these 5 go to one part of the hidden layer. And that hidden layer goes to this one. So you're taking 5 inputs and you're putting it into 5 parts of the hidden layer. So 5 times 5 would be 25. Already that's way more than you would if you didn't have this hidden layer. If you didn't have this hidden layer, it's gonna look like this. You just have 5 inputs and it goes to one output. But in this one, you have 5 inputs, 5 parts of the hidden layer, and then the output layer. So it's 25 times that you're training your program. So yeah, obviously compared to before, if you're training it 5 times versus 25 times, it's way more. So yeah, like I said before, deep learning or using hidden layers is basically just a way to train your program a lot more. And then this is something I mentioned before, but the multi-layer neural network, that is what makes deep learning. So like this, having a lot of different layers is what is called deep learning. So this H, so normally we only have X and Y, right? But now we have this thing called H. It uses X, and we have something called activation swish, and this H is basically just your hidden layer. So, yeah. This is another example of what the hidden layer does. And then basically, you're just creating like a bunch more perceptrons by using the hidden layers. So you're just training it over and over and over again with the hidden layers to get one output. Okay. So yeah, you're basically in the end, you're going to have a way more accurate program. And that's our goal because for example, this Boston housing one, let's say you're actually trying to calculate the cost of Boston houses. If you use this and it's not accurate, then it's it's obviously not going to work, and we don't want that. So we're just going to train it a lot more, and then it's going to become accurate. Okay, so like I showed before, we have X, Y, and then we have H is our hidden layer. That's what we're going to add to this program here. I'm actually so this one shows making one hidden layer, but I'm gonna make two in my program. So, if you guys can go to Google Drive and open up your Boston housing programs, then we'll just edit that directly. So I'll give you a little time to finish up the stuff before and then open this. And once you guys are done, let me know.
Content.
Okay, so once you guys are in your Boston housing programs, go down to the part where it says X and Y like this. It should look like this. So you can just go there and then we'll start editing it. So like I said before, we're going to make a hidden layer. And how you do that is you use something called H. It's basically the same as, it's going to look the same as your Y. But, yeah, let me show you guys. So we're going to do tf.keras.layers.dense, just like we did Y. But this time we're going to have 10. Again, this is the activation. And here I'm going to use X. So basically, I'm taking the input from X and I'm using it in this hidden layer. This is just like this one. So we have X here. We put it into this hidden layer. That's where we are right now. And then I'm going to make another hidden layer. How I do that is just the same thing. tf.keras.layers.dense 10. The only difference is that this time, instead of saying X, I'm going to use H because I'm taking from H. Now, our program looks more like this one. We have X here. We have our first hidden layer and our second one as well. So this second hidden layer, it takes from the first one, which is why I have X here instead of H. And we can make a third hidden layer as well. You can keep going, but I'm just going to make 3 for this example. And again, instead of doing X, this time I'm going to do H. So this first hidden layer took from X, or our input layer. Second hidden layer takes from the first hidden layer, not X. And then the third hidden layer takes from the second hidden layer. So that's what we have here. The first hidden layer takes from X. The second hidden layer takes from the first hidden layer. Then the third one takes from this one. And then make sure you edit Y. So right now we have 1 and X, but we're just going to change it to H. And then you can run this one to make sure that it works. Let's see. Oh, okay. You need to run everything. You need to run everything again because right now I just tried to run that one, but there's nothing called TF yet because I didn't run this. So if you guys want to run everything at once, go to runtime and there's an option called run all. If you press that, everything's gonna run at the same time. Okay. And right now it's just training. So I'm gonna leave it to do that. But I'll send you guys this part. Okay, I just sent my code in the chat. It's also in the live lecture notes channel, so you can look at either of those. Okay, so before our loss was 24, this time it's only 14, which is a lot less than before. So already it's getting a lot lower and lower. And then once we print dependent, now we have these new values. And let me open what it's supposed to use. Okay. So once we print dependent like this, it's supposed to be like 24, 21.6. So we have 24, 21.6. So far, so good. We have 34.7, 33.4. Yeah, the next 2 lines are also good. And then 36.2. So yeah, you can see now our program is a lot more accurate and it prints out the correct values that it's supposed to. So by only doing these 3 extra lines of code, our program basically does exactly what it's supposed to do now. And yeah, that's all for deep learning. And now I think okay, now I think David is gonna be doing a different fun program. If you guys have questions, make sure to put it in chat because I know this is really confusing. If you guys need me to go over it again, I can. But if you guys understand, then we'll move on.
Okay, so our next fun project is Hangman. So I'll just read what I wrote. So Hangman is a game where person A thinks of a random word or phrase, and when the game starts, person A only reveals how many letters there are with underscores. So for example, if the phrase is "Hello World," then person A only reveals this string over here. So hello has 5 letters, and world also has 5 letters. So so there's 5 underscores here and here, and there's a space to indicate the space. And then person B is asked to guess from the 26 alphabets, and then every guess, person A fills in the underscores if the letter is in the phrase, and if it's not, then person A takes away a limb. So basically, you start off with 8 limbs. So a limb is basically a chance. So you get 8 chances. So 8 incorrect guesses, and then if you use up all the 8 incorrect guesses, then you lose. But if you guess the entire phrase without losing all your chances, then you win. So, for example, if person B guesses the letter L, then person A updates the string to be this string because so hello has 2 L's. So as indicated here, there's 2 L's, and world also has an L over here. So that's how person A updates the string. If person A guesses the letter correctly, person B guesses the letter correctly. But then if person B, let's say person B guesses the letter S, the letter S is not in hello world. So the string isn't changed because there's no S, and then a limb is lost. So basically you lose a chance. And then you keep doing this until one of these 2 conditions is fulfilled. So so if the phrase is completely guessed, so if this turns into a hello world, like the initial phrase we had, then we stop the game. And then we also stop the game if we run out of limbs. So if we run out of chances. So your program should receive a string input and set it to the word. So set it to the variable word. So like hello world over here. So this program is going to allow the user to set their own word, and then so when the user inputs their word or phrase, it should be stored in all lowercase characters and should be validated to only alphabets, to only contain alphabets. So if it contains like numbers or symbols, so something that's not an alphabet, then the program shouldn't continue. This is because person B only guesses from the 26 alphabets. So there's 26 alphabets from A through Z. So we want to make sure that the initial word or phrase only contains alphabets. And we should set the variable remaining to 8 to indicate that we have 8 chances or 8 incorrect guesses before we lose. And the program should ask the user to guess continuously until the win or loss conditions are met. So these are the expected outcomes, but before that, I'll go over what we have to know to solve this problem. So this problem demonstrates, so you will demonstrate your knowledge in using the while loop, strings, and lists, and you will also display your understanding with reading inputs, using if-else statements, and printing strings. And so these are the expected outcomes. So let's say the initial word was hello world. So first, the program should print how many letters there are using underscores. And then let's say the user inputs the letter O, then the program should say that the letter O is in the word because there's 2 O's in this phrase. So the program should say that it's in the word, and then it should also update the string to include the O's. And then let's say the user then guesses the letter S. So S is not inside the phrase hello world. So we had 8 limbs to begin with, 8 chances. So since the user guessed incorrectly, we should take away a limb, which is basically subtracting 1 to the variable remaining, which was initially set to 8. And then we should print the updated value, so how many chances we have left. And then we should print the same string because the letter S was not in the string, we just print the same thing because nothing changes. And if we guess H, then there's an H in hello, so the program should print that H is inside the word, and then update the new string to reflect the changes, so with the H. And then if we guess T, then letter T is not in the word, so we subtract 1 from the amount of limbs or the amount of chances, and then we print the same thing, and we keep going until we either finish the phrase. So over here we guess the letter R, and then we just need 1 more, so the letter D, and we guess the letter D here. So over here we finished the entire phrase, so the program should print congrats, like a congratulations message, and then print that data string, which should be completed. And then if 1 limb remains, and then the user guesses an incorrect letter, so normally you would subtract 1 to the remaining limbs. So 1 minus 1 is 0. So you have 0 chances remaining. So the program should print that you're out of limbs and what the word was, and then the program should stop because you lost. So that's an end condition. So the program should stop at 2 conditions. So one of them is if you guess the entire word or phrase, and then it also stops if you run out of chances or limbs. So that's that. So it might be confusing, but once we start it, hopefully it becomes more clear. So first things first, open VS Code and make a new file that ends in .py. So you can do that by clicking here that says, so right here that says new file, or you can also right click and click new file, and then you can name it, but then just make sure that it ends in .py so that the compiler knows. So for me, I named it hangman.py to organize it better. So according to the problem, we want to receive a string input, which is going to be the word, and then set it to a variable, and then initialize how many chances we have. So we can start off with that. So get word and validate inputs. So that's a comment. As we know, that's not actual code, so the program ignores that. But as programmers, it makes it easier to like organize your code, I guess. So first, we want to get an input and set it to a variable. So word equals inputs. What should the word be? And then, so what it does is it prints the string, and then it takes an input, and then it sets it to the variable word. So now we want to check that word only contains alphabets. So no numbers, no symbols, just alphabets, so that the game is actually playable. So if not, so I'll just type it first and then explain what it is. So here's a statement, an if statement. So there's the word if and a condition. So you might so you might have not seen this attribute before or method. Dot replace. So what it does is it literally replaces a space with a blank. So whatever you have here with whatever you have here. So these two things are not the same thing. There's a space here and there's nothing here. So what it does is it replaces spaces with blank. So it just removes spaces and then it returns a string. So this thing is a new string that doesn't have spaces. And then dot is alpha. It's a function that returns true if the string is only alphabets, and false if it's not just alphabets. So if it contains like numbers or symbols, then it returns false. And we also have a not keyword here, so that we reverse the outcome. So if it is alphabets, we're fine with that, right? So, but then if it's not alphabets, we're not fine with it. If it's not all alphabets, then we want to stop the program. So prints the word must only contain alphabets and spaces, I guess. And then we exit the code. So exit with the parentheses, that stops the program. But before we stop it, we want to print like why it stopped, right? So that the user isn't confused as to why it stopped. And we want to print it before we exit, so that it actually runs this part and then we exit it. So another thing is why we get rid of spaces is because is alpha only checks if the string just contains alphabets. So if it contains spaces, then is alpha is going to return false. So we want to allow spaces because, as we see here, hello world should be valid, but there's a space in between, and spaces are not considered to be alphabets. So that's why we want to check. That's why we want to get rid of spaces just for the check. So that's part one. Let me know in chat when we can continue.
I'm sorry.
Okay, so I'll continue. So our first part gets an input and then it checks if it's only alphabets. So that's the first part. So now we want to initialize the rest of our variables. So declare variables, and then remaining equals 8. So we have 8 chances or 8 limbs. So that's the variable that keeps track of how many chances we have left, and then we want to turn this the string into like a list. So we want to list it and then dot lower so that it's just lowercase. So technically our user can type in like hello like that, like a mix of upper and lower, but we want to make it into 1 so that, so let's say if the user later guesses h, so if it's lowercase h, then lowercase h so lowercase h is not equal to capital H. So to prevent having this issue later on, we want to lowercase everything. And then, so it might not be clear why we initialize these variables, but I'll explain them as we continue. So basically, this is the amount of chances we have remaining, and what this does is it turns the string into a list. So it's probably better if I show you guys. So Python, so list. So let's say our word is hello world. Then this is what it does. So that's a list. So it separates each character into its own list item. So we have HELLO, like what we expect in this order. And then note how there's also a space, because a space is technically a character. And then we continue, so WOROD. So that's what it does. So it turns the string into, it separates it into different, like all the characters it has basically. And then current and then guesses. Yeah, so it's a bit complicated if I explain like right now. So as we go on, I can explain it better. So that's our second part of the code. I should probably make this into this line, so it separates better. So type done in chat if you're done copying the code. Okay. So after we declared the variables, the next part is to initialize string and then print it. So so remember how over here, so we want to turn the phrase hello world into this format. So with the underscores, so we want to print it first and save it to a variable. So how we do that is we so we want to iterate through every character in Word, and then we append it to the list currents depending on if it's an alphabet or a space. So if it's a space, so if the iterated value, so like this part over here, if it's a space, then we want to have a space. But if it's a letter, we want to have underscores. So first we want to iterate through all the letters. So for letter in Word, so there's two scenarios. So if the letter is an alphabet, then we have then we do something, and then the second scenario is if it's not a letter. So if it first of all, if it is a letter, then we want to append the underscore. So basically, the current is going to contain this string in the form of a list. So okay. So if it is an alphabet, then we want to append an underscore. But if it's not, then it has to be a space. So currents dot append a space. So this string isn't empty. There's a space. So what these line of codes do is it iterates through our secret word, and then it checks if it's an alphabet. So if it's a letter in the alphabet, then we replace it, or not replace, we just append an underscore. And if there's a space, then we also want to represent that. And so basically, H is an alphabet, so we append an underscore. E is an alphabet, so we do the same thing. But then when we get to here, that's a space. So we want to make a clear distinction that there's a space. So that's why we do this. Did someone DC? They're back. Welcome back. So
Thank you. May you repeat from where you ended?
yeah, sure.
Because we could not see them.
So after we declare the variables, next we want to initialize the string and print it. So what I mean by the string is the string we have here. So first we inputted the word hello world, and we want to turn the string into this string that we have here. So that's what I mean by printing the new string. So so in order to do that, we have a variable called currents that stores a list, and we want to append underscores and spaces. So as we see here, so hello world. So H is an alphabet. So in place of the H, we want to append an underscore. And then next we have an E, so we append another underscore. But then when we get to here, there's a space. So to reflect the space, we also want to put a space here so that we know that there's a space. So it's two words. So yeah. So basically, alphabets, we append an underscore, and for spaces we just append a space. So that's what we do over here. So word is the string that we inputted. So so that's the word, and we want to iterate through the word. So and then get the individual letters. So 4-letter in word. So that's a for statement that iterates through all the characters. So HELLO space. So that's what it would iterate through. And then we have two scenarios. So if the letter is an alphabet, so if it's an alphabet letter, then we want to append the underscore. And then the second scenario is if it's a space. So if it's not an alphabet, then it has to be a space, right? Because over here, if it's not just alphabets and spaces, we ended the program over here. So so it can only contain spaces and alphabets because the program would never make it this far. If it had like numbers or symbols, then the program would have stopped before. So um, if it's not an alphabet, then we can assume that it's a space. So we append a space. So now the list currents has the order of what to print in a list. So now um, instead of printing a list that looks like this, so that's what a list looks like. So that's not very friendly to humans, right? So to just print it in order, we um so we join it with the current list. So basically what this does is um so for every letter in currents, it just appends it. So it's probably better if I show you guys. But before I continue, let's also print that you have 8 chances or limbs and then start guessing. So let's say you set the variable s to hello or not. Or we can list it first because that's how the join method works. So as we see here, uh, list hello world. So this is the line from before. This is what it does. It separates each character into its own item in the list. So HELLO. So that's how the string goes in order. And don't notice how there's also space because a space is technically a character. But then what if we want to reverse this? What if we want to turn this back into its original string? So that's what the join method does. So how you use it is you have a blank string and then you write dot join and then uh, the list variable or the list. So s in this case. Um, so yeah. So this is so with by using the join method, we can turn a list like this back into the original string. So notice, so recall how current is a list that looks like this. So each character is something like this, but instead of letters, it's underscores and spaces. But we want to turn it back into string. Okay. So we want to turn it back into the string so that this is what the user sees instead of a messy list. So that's why we use the join method so that it turns it back into a string. So yeah, so now we initialized the string into the underscore format and then we printed it. So as expected here, so we have the word and then we print it in this format, so underscores and spaces, so that each letter is replaced by an underscore and spaces replaced by a space. So in this format, so that's what we did here. Yeah, so that's printed.
Can you copy the code and share it?
Oh yeah, I can share the code, yeah, of course. Okay, great. So I'll just continue. So while you were writing this part of the code, you might have asked, why do we make a list? So instead of just doing a string, so why do we do a list? So later on in the code, so we want to edit um, this string. So as you can see here, after the user starts guessing, we want to edit the code, I mean the string, so that it reflects the changes. But if we have a string, it's a bit harder to do that. So if we have a list instead, we can use indices and then we can edit it uh, uh, easier. So that's why we use a list instead. Um, so after we printed the initial string with the underscores and spaces, now we want to have a while true statement so that it runs forever until we tell it to stop. So now we want to take the guess and then validate the inputs. So while true, so guess is our guess. So inputs. So what this does is it asks the user for an input and then it sets it equal to guess. So and then remember how each guess is only one character long and the user might accidentally type more than that. So we just want to count the first letter. So let's say the user types in like hi, then if we do that, then guess is only going to contain the letter H because it only stores the 0th index, which in every case is the first letter, so that we can ensure that each guess is only one letter long. And then we also want to dot lower it. So remember over here, oops, over here we established that lowercase h is not equal to capital H. So if you set it equal to each other, then the program is going to say they're not equal because one's lowercase, one's capital. So to to not have this issue, we want to lowercase everything. So remember over here, we turned the word into all lowercase and then set that equal to answer, so that we only have to deal with lowercase letters. So yeah, so we can set everything to lowercase, so the guess to lowercase, to the answer into lowercase, so that we can compare it without having capitalization issues. So that's our guess. So that contains a lowercase character, a singular character. But now we have to validate that it is an alphabet. So how we do this is we check if it's not is alpha, then we want to print your guess must be an alphabet, and then keep going to tell the user that the program didn't stop, and then we can have the continue keyword. So what this does is it stops the iteration, the current iteration, and then it starts a new iteration. So the code goes back to here basically. So it doesn't continue like to what there's below it, but it starts from the beginning, a new iteration. But if it gets past it, then we know that it's an alphabet. So if guess and guesses, then prints next we can use an option. You already guessed the letter guess, and then keep going. So this might be new to you. So if you have an F before you start a string, then inside curly brackets, you can actually use Python variables, and then it replaces that part of the string with the variable. So did someone disconnect? So welcome back. Um, should I explain everything again? Okay. So basically, the variable guess stores the lowercase, so one character that's lowercase. So if you type in I, then it only stores the letter H. But normally the user should be inputting one character responses. But just in case there's more than one, like by accident, then we just take the first character using the 0th index, and then we lower it so that we ensure that it's lowercase, because as we mentioned here, we stored the word in lowercase form into the answer, so that we don't have any capitalization issues. And then over here, if the guess is not an alphabet, so if guess dot is alpha is not true, then we want to print a warning that says your guess must be an alphabet, and then keep going to remind the user that the program isn't stopped, and then continue so that the rest of the code does not run. Instead, what it does is the code goes back to here so that it starts a new iteration. So it asks for another input that is an alphabet, and hopefully it is, then it won't. Oh, they disconnected. Welcome back.
Thank you. Sorry, there was a network problem. May you continue?
Okay, so yeah, so if it's not an alphabet, then we want to print that your guess must be an alphabet. And then, so if it's not guess dot is alpha, that means that it's not an alphabet. Then we want to print this warning as I said before, and then we want to continue. We want to have the continue keyword so that the rest of the code inside the statement does not run, but instead a new iteration runs. So the program asks you for another guess, and hopefully this time your guess is an alphabet so that this part doesn't run, but it continues, hopefully. So so remember how we initialized the variable guesses here as a list? So what we're going to do with it is we're going to append every single guess that we make into this list so that we can check if we already guessed it. So if guess in guesses, so if our letter is inside this list guesses, then that means that we already guessed it. So you already guessed this letter, and we want to continue so that the user can guess a different letter. And then if it's not already guessed, then we want to add it to the guesses list. So dot append, that's how you add an item to a list. So you add guess to the list guesses because it's not already inside. It's not already there. So let's say we already guessed it. Then this has to be true, right? Because the letter should already be in the list guesses. So this should run, which means that the continue keyword starts a new iteration instead of continuing. So so the program asks the user for another guess because we already guessed it, and then hopefully the next time around the user guesses something else that's not already guessed, so that the code continues. So the code continues by adding our guess into the list guesses so that the next time around we don't guess the same thing. It looks I think they disconnected again. Uh, yeah, I posted the code in live lecture notes. So can you guys see the screen? Hello?